few, which I'm going to go over. And as soon as it starts recording, I'll begin. Okay, I think we're good. All right, let's start. So the first one I want to go over is index numbers. All right, so let me share my screen and I'll show you. These questions that I'm working through is from a past year paper. So if you can't see my screen, just let me know. All right, so this is a typical kind of question on index numbers that you can expect. I'm just disabling thing. All right. So the following table indicates the unit prices in rands and quantities of 3 products sold by a company called Better Bathrooms for the months January and March. So you're doing a comparison between January and March. So always for index numbers, you're going to be doing a comparison between 2 periods. One of them will be your base period, and they will tell you which the base period is. In this case, they're telling you that the base period is January, so January 2024. All right, so let me use a different color. Blue. Okay, cool. All right. So for each of these products, basins, taps, and shower doors, you got the prices in January and you got the quantity in January. And then you have the same things for March. So question 2.1 asks, using January as your base period, compute the price relatives for basins and taps. So you have to do it for both of these items. When it's just the price relatives, you don't take price and quantity into account. Okay, it's not a weighted index. So all we need to look at is the prices for basins and taps. Let's do basins first. Okay, so if you're doing basins first, all we need to do is compare the latest period, which is March, to the older period, which is January, and that's the base period. So we want the price in March, which is P1, right? So P1 is for March, divided by P0, and we multiply that by 100%. So we convert that to a percent. Now the price for basins in March, if you look at the table, there it is there, 549.4, 549.4, divided by the price in January, which is 557. And you convert that to a percent, you get a value of 98.64%. 98.
Open for Daniel, please.
Sorry. Could you just, everyone else, could you just mute your mic unless you want to ask a question?
Sorry,
so
apologies.
Please, everyone, could you just mute? No worries. All right, so let's continue. So we got 98.64% for basins. Now that is less than 100%. So immediately we know it's a decrease, right? If it's less than 100%, it's a decrease. How much did it decrease by? All you need to do is subtract 100% from it, right? So it's 98.64% minus 100%, and that gives you a value of negative 1.3%. So all that's telling you is that the price of basins has decreased by 1.36% from January to March. Okay, you need to state what I just said. Okay, I'm not going to write it out, but just make a note of that. Anyway, I'm recording this so you can watch it again. So remember to make that statement to interpret your answer, right? Price of basins has decreased by 1.36% from January to March. All right. So we'll do the same thing for taps. Okay, so we're going to do the exact same thing for taps. It's the same procedure. We just change the values. All right, so the price for taps in March is 240.5. the price for taps in January is 242.5. Right, you work that out and you get 99.18%. And then we subtract 100 from that, right? So we'll take this value, we'll subtract 100% from it to see how much less than 100% it is. And that value is minus 0.82%. So all we need to state is price for taps has decreased by 0.82% from Jan to March. All right, and that's question 2.1. Right, you did it for basins and you did it for taps. Okay, now let's move on to question 2.2. Now we are going to work with, oh, okay, great, weighted indices. And specifically for this question, they want us to look at the last price index. Now the formula is given to you, so I'm writing it out, but it is in your formula sheet, so you don't have to memorize it. Okay, so the last price, it's simply the sum P naught, Q naught, sorry, my bad, P1 Q naught, P1 Q naught divided by the sum of P naught Q naught times 100%. That's the formula. And all we need to do is find those values in that formula and substitute in it. All right, so this numerator, it's a product of P1 and Q naught. The denominator is a product of P naught and Q naught. I'd advise you to just create these columns in advance. All right, so you're going to have 4 columns basically. You're going to have a column P naught, Q naught. So I'm going to put this on the right. Second. Yeah. We have another column. Yeah. Okay, so P1 Q naught. And then you're going to have a column for P naught Q naught. So for the first column, you're taking everything in column P1, which is here, and you multiply it by your Q naught column, which is here. All right, each value, we multiply them together and you write the value here. So if we do that, okay, so the first value is 217013. The next one is 1827780. And lastly, 624035. 0.5. It's a 0.5 there. Okay. All right, that's P1 Q naught. And then write the total of these values. So add all these values up. Okay, so add these 3 values up, you get a total, and that is 1023. It's quite a big number. Zero two three 828.5. Okay, now you're going to do the exact same thing for this column here, right? Now you're going to multiply P naught and Q naught. So you're going to multiply these 2 columns, P naught and Q naught. Right, you'll do that, you'll write the values out, and you get a total here as well. So I'm just going to do the total, okay, because I assume you understand how I did the column before. So it's the same method for doing this column, right? So the total for this column, all right, is 1030. 0 and 0.5. So here, this P naught Q naught is your denominator, all right? And your numerator is the total in the previous column. So you'll substitute that into this formula here and here and work that out in your calculator. And if you do that, you'll get a value of 99.4%. So this answer is 99.4%. All right, now you need to interpret it. Okay, so because it's the Lasperus price index, you can look at your formula to see what's being kept constant. In other words, what is the same in the numerator and the denominator? Now, if you look at the formula, you will see that Q naught is in both the numerator and in the denominator. And what that's telling you is that that's what you're keeping constant. So you're keeping Q naught constant. But when you're interpreting it, don't say keeping Q naught constant. Say what it is. Q naught represents the quantity in January 2024. Right? So all you need to say is holding the quantity UTY in January 24 constant. All right. The price of better bathroom items decreased, because we know it decreased, right? Because it's less than 100. So it decreased by, and whatever this is less than 100 by, you can just subtract 100 from it, and that's the percent that you would have. And in this one, it's kind of easy to see. It's a decrease by 0.6%. You don't have to say decrease by negative 0.6. The fact that you mentioned decrease already signifies that it is a negative number. All right. So this is how you would interpret it. You must say what you're keeping constant, and you have to say, oh, even I forgot this. Oof, sorry. I didn't say from which period it decreased. All right. So I have mentioned what's kept constant. The price of better bathroom items decreased by 0.6% from Jan to March. This is the last part. Even I forgot to mention that. All right, so you need to say how much it decreased by, all right, what you kept constant, and which periods. All right, that's the three things you have to mention when you're interpreting these weighted indices like Lasperus and Bosch. Okay, now we're going to do 2.3, and it's very, very similar. It's just using a different formula. So I'll write that formula out. Okay, now we're going to use the Bosch price index, okay, for 2.3, and that formula is sum. Oops. Just give me a second. Let's see. Did I stop sharing? Let me just. Okay, let me know if you can't see my screen. Okay. Start recording. Okay, cool. All right, so now we're going to do the Bosch price index, which is question 2.3. And the formula for that is P1 Q1 over sum P naught Q1 times 100%. All right, so that's the formula we use for the Bosch price index. So the same thing like what you did earlier, except now you're going to create two columns, one for the numerator, which is P1 Q1, P1 times Q1, and for the other column, it's going to be the denominator, P naught Q1. And then I think you know how to do these columns. If you're looking at P1 times Q1, then here's your P1, here's your Q1. So you just multiply these two columns and you place the multiples there, and then you get the total. And the total, I'm just going to do the totals for both of them. You have an idea. P1, Q1, it's 1,073. Three, 788. And then for P0, Q1, it's 1,080. 188. All right. And then all you do is you substitute these values into your equation and get the value. And if you do that, you get a value of 99.41%. Try to round to 2 decimals, okay? Make it a habit for all your answers. Don't go less than that. If you want to go more, it's up to you, but at least 2 decimals. All right, so 99.41%, excuse me. So this has decreased by, so how much is it less than 100%? You can subtract 100% and you'll get a decrease of minus 0.59%. Right, so when you're interpreting, right, I just made a note of this here, but I'm not done with my interpretation. So here, what are you keeping constant? If you look at your formula, the value that's constant in both is Q1. So that means you're keeping Q1 constant, which is your quantity in March. So your interpretation would be holding the quantity constant in March. So you notice I didn't put Q1, even though I know it's Q1, but I'm showing that I know what Q1 represents. All right. The price of better bathroom items decreased by 0.59% from Jan to March. Okay, that's how you interpret it. Make sure you have all of those details. Any questions on this before I move on? Please ask away. But I'm just going to assume so far so good. All right, so that's typical kind of questions you can get for index numbers and how to go about answering them. Don't forget to interpret them. Please interpret your answers. Maybe some advice also, if you're stuck with something, all right, if you're really struggling to figure something out for like 2 minutes and you can't get it within 2 minutes, move on to the next question, come back to it. You are pressed for time, remember that. So you got to work fast. So use that as a guide, okay? 2 minutes and you still haven't struggled to work out anything or write anything down, move to the next question. Okay, let's move on to the next one. All right, so next question, question 3. Now, this question is about using regression. Okay, obviously the question won't tell you to, which learning unit it belongs to, but you just need to be able to identify that. Keywords you look for is the line of best fit, coefficient of determination, correlation. Those words will indicate which section that this question belongs to. So here you're given a table of data, your age in years, and the market value for SUVs. So basically, how old the SUV is. So in the first row, the SUV is 3 years old, and the market value of that SUV is 425,000. So as you can expect, the newer the SUV, the higher the value you can expect. Now, you're not guaranteed to be told which is your X and Y, right? Sometimes in this question, it happens to be the case, but don't always assume that they will tell you that. You need to figure that out. You need to figure out what influences what, right? So in this example, you can kind of gauge time is not affected by anything. So this would be your independent variable, age, right? Something is going to age irrespective of anything because of time. But the market value is dictated by the age of the vehicle. So that's why your age would be X and your market value would be your Y variable. And you would use your calculator to capture these numbers, okay? So you have to use the regression function to capture it. And when you do that, once you store the data in your calculator, you can then easily get the totals that's required for these variables here, right? So when they say total of X, what they're asking you is, for this first column, they want you to enter sum X. For this next column, they want you to enter sum Y. And the next one, sum X squared. And the last one is sum XY. Now you can get all of these values from your calculator once you stored the numbers in your calculator, all right? And then to pull out these sums, right, I did show you in the lesson. So please, if you're not familiar with that, watch that lesson again. And I showed you how to use the calculator to pull these values. But you'd have to use Shift 1 and then look for the sum option, because that's what this sign means. Sum, right? So that's what you're looking for. Now, if you get all these values, enter it in the paper. Okay, you need to show these totals because you get marked for it. So in this question, the totals will be your sum X, which would be 45. Your sum Y would be 1,885. All right, for your sum X squared, it's 531. And then your sum XY is 15,765. Okay, so show the totals. All right, now we're not done with that. If you look at the first question, they're actually asking us to work at the line of best fit. So you would have to use the equations in your formula sheet to get that. So the equations, here it is here. All right, so to get your slope, you'd use this formula here in your formula sheet, so you don't have to memorize it. And then your intercept is given by this formula. So all you're going to do is plug those sums into this formula and get the values. So in other words, let me just do the slope for you. For your slope, here, if you wanted the slope of the line, which is b to b1, that is given by n sum xy minus sum x sum y times sum y all over n sum x squared minus sum x all squared. Now n is simply how many rows of data do you have. If you count the number of rows, right, you'll see that your n is 5. So here our n is equal to 5. Now we have all the values to plug into this formula. It's in this table that you just populated here, right? Yeah, in this table. So if you plug all those values in, and you do need to show that you're feeding the values into the calculator. You can use the shortcut to get this, okay? But if you see a mark scheme of 12 marks, don't use the shortcut. You can use the shortcut just to check that your answer is correct. But you need to show the workings, all right? I'm emphasizing that. You show your workings for the intercept and the slope, like what I'm doing right now. So I'm going to substitute all the values into the formula. So it's going to be 5 for n. And your sum xy, here it is in the table. It's 15,765 minus some x, which is 45, and some y, which is 1885. Divided by n, which is 5, times sum x squared, which is 531, minus, please make sure you understand the difference between these two, okay? This is the sum of your each x value squared. Here, this is the total, and then you square it. So we're squaring this number here. All right, and if you work that out, you get a value of minus 9.52. Minus 9.52. That's your beta 1. And then your intercept is given by the formula sum y minus b1, which you just worked out, times sum x all over n. Now, if you plug those values into the formula, you're going to get some y, which is 1885 minus 9.52 times some x, which is 45 all over 5, and that gives you a value of 462.71. 462.71. All right, so you found your beta 1, or your b1 and your beta, keep saying beta, your b naught and your b1. All right, so now you just need to write out the equation. So the equation of the line is y equals b naught plus b1x. And all you need to do is say what those b1 and b1 values are, which you just worked out here. So it's 462.71 minus, because your b1 is a minus, 9.52 x times x. And remember to say for what values of x this equation is valid for. Now, this equation is only valid for the lowest value of x and the highest value of x. So it's only valid for, I can write it mathematically like this, 3 less than equal to x less than equal to 17. Or you can write it in words, for x between 3 and 17. It's up to you. Okay, so you must state that this equation only holds for the lowest value of x and the highest value of x. All right, make sure you state that. Now, all of this that I've done is just question 3.1. All right, and that's your 12 marks. So all of this working you'd have to do and show in order to get those marks. So that's 3.1. Now 3.2, all right, it's not as much work. As you can see, it's only 3 marks. So I'm going to clear out, oops, I'm going to clear out this, but I need my equation on the top, because I'm going to use that equation to answer that question. Okay, so question 3.2, if the SUV is 15 years of age, estimate its current market value. So I'm going to use this equation to get that estimate. All I need to do is plug 15 into x, because that's the age they want me to use. So for question 3.2, I simply just use that equation. So it's going to be my predicted y is equal to 462.71 minus 9.52 times x, and the x value they want me to use is 15. So feed that into the equation, and the value you will get is 319.87, no, 857, 319.857. Now remember, I'm not done because the market value is in thousands. So I need to convert this to what the actual value is, okay? Because an SUV, yeah, you're not going to find an SUV for 319 rands. So you need to write the full amount. So it's in thousands, so all I need to do is multiply it by 1,000. So the full value is 319.857 times 1,000, and that'll give you 319,857 rands, right? Is the price of the SUV. I would say estimated price. The SUV. That's how you use the equation to get your predicted value. Okay, so that's 3.2. Okay, so all of this that I've done, you need to show, right? How you plug your X value in, get the amount you're interested in, and then convert it to the units that you need to interpret it. All right, now question 3.3. Use your calculator to compute the coefficient of determination for the data set. Okay, so it tells you use your calculator, don't use the formula, all right? The coefficient of determination is your R squared value. Now, if you store this data in your calculator, you can get R from your calculator. So you can just get R from your calculator. And remember, you would use shift 1, use the REG function, and then, because the REG is regression, and then look for R. Now, if you do that, right, your R value that you're going to get is minus 0.987. I'll put one more decimal, 971. So if that's R, then your R squared is just squaring this value. So your R squared is just squaring this entire thing and expressing it as a percent. And if you do that, you'll get 97.43%. And then you must interpret your answer. The question even tells you that. Interpret your answer. How you interpret your coefficient of determination is you look at the value you got. And what it's telling you is that it's telling you that 97.43% of the variation in your Y can be explained by X. But you are not going to write Y and X in your interpretation. You need to interpret it in terms of this problem. So you would say 97%, right, of the variation of the market value of SUVs can be explained by the age. All right, so don't use Y and X. You need to apply that to the problem. Okay, that's how you interpret that. So remember to write that down. Okay, so that's question 3. If there's no questions, yeah, please feel free to ask any questions on it if you're not sure about anything. Let's move on to, okay, another question I want to show is, give me a second, probability. So let me open that. Okay. Let's go to this question here. Oops, hang on, I'm going to show it in my tablet so I can write on it. Second. Okay, and break it. Come on. Okay, great. Okay, question 6, right? So here, this tests you on probability. So let's look at the first question here. A bag contains 11 red and 6 blue marbles. You are asked to select 2 marbles from the bag, and the first marble that's selected will not be placed back into the bag. So this is sampling without replacement. Okay. So the first question wants us to construct a probability tree. So when you construct your probability tree, you're going to start off with a single point here, and it splits because you have 2 options. You can either choose a red or you can choose a blue marble. So let's go with the case where we choose a red marble first. So you have 11 red marbles and you have 6 blue. So in total, you have 17 at first, right? That's the total at first because you're adding 6 and 11. So the probability of a red marble is 11 out of 17. So you could have a red marble with a probability of 11 of the 17. And in a similar way, you could choose a blue marble with a probability of 6 over 17. Now that's in your first draw. Okay, so everything that I'm doing here, I'll draw a vertical line down here. This is your first draw. All right, that's your first draw. Now after that, this is your second draw. Now remember, the question tells you that you will not place that marble back into the bag. So if you already drew a marble in the first draw, that means that you 1 marble out of the bag. So now you're left with 16 marbles, right? You're left with 16 in the second draw. I'm going to put a 16 here so we know that that's the total for the second draw. Now, just like before, you can also have 2 possibilities here. You can either choose a blue or you can choose a red, right? So here, the probability of a blue marble is, remember now, you have 16 marbles in the second draw. So your total, your denominator is always going to be 16 here. But how many blue marbles do you have in the second draw? Now, if you are following this path here, that means you chose a red in the first draw. So that means there's still 6 blue marbles, right? You haven't touched that. So you are left with 6 blue marbles here. Okay, that's your probability of a blue marble in the second draw. On the top, it's the chance of a red marble. So we know our denominator is 16. That doesn't change. We still have to 16 marbles. But how many red marbles do we have in the second draw if we're following this path? Now, this path tells us that we drew 1 red marble. That's why there's probability of red here. That means we took a red marble out. So that means we're now left with 10 red marbles because we had 11 in the first draw. We drew 1, and now we're left to 10. Okay. Okay, so now we do the same thing here, right? This path. We're going to follow this path. It can be split into 2, where we can choose a blue marble here. All right, and we can choose a red marble here. So here, we're still going to have 16 in the second draw. So 16 is the same denominator throughout the second draw. Remember, in your second draw, you're always just going to have 1 less in your denominator than in the first draw. First draw, you had 17. Second draw, you have 16. So now the total is 16, right? So we know the denominator is going to be 16. Now, if we are following this path here, that means we chose a blue marble already in the first draw. So that means we are left with 6 minus 1, which is 5 blue marbles. And here for the top, because you chose a blue marble going down this path, you haven't touched the red marble. So you're still left with 11 red marbles here out of 16. All right, so these are the probabilities in the second row. And these are the probabilities in the first row. So your final probabilities is just multiplying them out. Follow the path, you multiply these two out, and you'll get a value of, but this one it is, tell you, 55 over 136. And remember to simplify the fraction, okay? Don't just multiply out, and your calculator generally, if you have the Casio calculator, it would simplify it for you. But leave the answer, you can do this two ways. You can leave it as a simplified fraction, like what I'm going to do. So this is the probability of red and red, red and red, which is 55 over 136. And here we're going to follow this part. So it's this times this. So this is a probability of a red marble and a blue marble in the second row, which is 33 over 136. And we do the same thing for the other parts. So here it's a probability of a blue and then a red marble, which is also 33 over 136. And lastly, it's a probability of a blue marble in both rows, which is 15 over 136. And that's your probability tree. Okay. So that's question 6.1.1. Now, question 6.1.2, you can use the result from your probability tree to answer this. What is the probability that two select marbles will be different colors? Now, there's only two cases where they're different colors, and that's here and here. Now, it's those two cases that we're interested in. So all we need to do to find that answer is we add those probabilities up. And if you add those two probabilities up, that's your answer. So the probability, the answer is 33 over 136 plus 33 over 136. I'm just going to write it as a percent. This is 48.53%. 48.53%. And that's your answer. All right, for 6.1.2. All right, let's move on to 6.2. So this is a different problem. I'm going to erase this. We don't need the tree anymore. All right. The probability, right, that a randomly selected employee of a company was born in South Africa is 0.8%. So I'm going to use some shorthand notation to represent someone being born in South Africa. So let's just say SA means born in South Africa. All right, so the probability of SA is 0.8. Then it tells me the probability that an employee of the same company works in the design department, given, this is important, given that the employee was born in South Africa, is 0.25. So here, there's an event that they're telling us about. It's the chance of someone that works in the company is in the design department. So let's let D be the event that someone is in the design department, that an employee is in design department. So what they're telling us here for this 0.25, they're saying the probability that someone is in the design department, given, which is the vertical line, right, that the employee was born in South Africa, is 0.25. So they're giving us these two probabilities. And they're asking us to solve what is the probability that a random selected employee of the company was born in South Africa and works in the design department. So what they want us to work out is work out the probability of D and SA. That's what they want us to work out. Now we can relate these three terms using our conditional probability formula. In your formula sheet, you have this formula here. Probability of A given B is equal to the probability of A and B all over probability of B. Now, instead of A and B, we have D and SA, which is the same thing. All I need to do is replace the A and B with SA and D. All right, so here, I'm going to replace it with saying B will be SA. So B will be SA. D will be A, all right? And this is SA and D. And I just need to rearrange this because I need to solve this. So to rearrange it, it becomes probability of D and SA equals probability of SA times probability of D given SA. That's it. And then all you need to do is substitute the values. For this, we know the value is given to us, 0.8. And this is 0.25, which is also given to us. All right, and you work that out. Plug into your calculator, and the answer you'll get is 20%. So you use the conditional formula. And you know you have to do that because they give you the keyword here, given, right? And that's a keyword to know that you have to use the conditional probability rule. Okay. All right. Let's move on to 6.3. All right. Beth is the manager of a data analysis department of some company. She has 19 staff members working for her, but she has to choose 9 of those staff members to attend a conference in Zurich. What is the probability that you would select the same team as Beth? Now remember here, if you're selecting team members, it doesn't matter on the order, right? So if I select James, then I select John and Sarah. It's the same thing as if you select Sarah first, James second, and then John third. It doesn't matter. The order does not matter. It's the same team. So we know we need to use combinations because order does not matter. Because we're selecting a subgroup from a bigger group. So we know you need to use either combinations or permutations. So here, what we're trying to work out is how many different types of possibilities are there of selecting 9 out of 19. So we need to work out 19C9 using your calculator. And if you work that out, you will get 92,378. That's how many different ways you can select 9 people out of 19 staff members. But they want us to work out the probability. So all you need to do to get the probability is just use this as a denominator and work out 1 over that number, because you have a 1 in 92,378 chance. Because remember, think about it this way, right? If there's 10 ways that something can happen, and you want to know the probability of one of those possibilities, then it's just a 1 out of 10 chance, right? So think about it this way. There's 3 cars. There's a blue car, a red car, a green car. And if I asked you, what's your probability of getting a green car? Well, only one of those green cars, one of those cars are green. So it's a 1 in 3 chance. So it's the exact same thing here. We have 92,378 possibilities. So the probability is simply just 1 over 92378. You can convert it to a decimal percentage. It's up to you, but it's already simplified. So this should be good enough. All right. So this is question 6.3. Now for question 6.4, it's very similar. Here you have 14 teams in a league, and you want to work out the probability of correctly predicting the top 5 teams. Now it does matter about the order, because it says, the question even tells you in the correct order. So it means you need to know, even if, let's say you're at first place, second place, third, fourth, and fifth place, right? Let's give these teams bull. I don't know rugby very well, right? So excuse me, Sharks and Cheetahs. Okay, so I'm gonna ignore this. Let's just say we had them in that order. If, however, Sharks was now first, then Bulls, and then Cheetahs, even though they're the same teams, it's not the same thing, okay? Because the order matters. Because now Bulls would get a gold medal, right? And Sharks would get a gold medal in the second one, or trophy, right? The prize, the grand prize. So the order does matter. So now it's not going to be combinations, it's going to be permutations. So the P. So now you're selecting from a group of 14. So it's 14P, and the number of teams is 5. So it's 14P5. And if you work that out, you will get 240,240. And like I said, if you want to convert it to a probability, because that's what the question is asking for, it's simply just a 1 in 240 chance. That's the probability. All right. Okay, everyone, that's what I wanted to cover this evening. I'm hoping everything made sense. And I'm not sure if you started revising already, but I hope you have. But please start working through problems. I'm giving you quite a lot of problems after every synchronous session, so I hope you have been working through them in the workbook. Yeah, and then you can start working to pass your papers. And if you're not sure about anything, please just, you can drop me a mail. I'm giving you a disclaimer right now. If you contacted me a day before the exam, it's very unlikely you're going to get a response. Okay, I'll try my best, but one day before the exam, it's going to be tough. So please start your revision earlier than that. And if there's anything you're not sure about, contact me before that. All right. That is it from me. This is my last session with you for the semester. I think there might be a support session, a recording for the summative. But I want to take this opportunity to wish you all the best, study hard, and work on speed, okay? It's not enough to just understand how to do the questions. When you're practicing, set aside one of the papers and try and work through it like in the same time that you have for your exam, and then see how you do and what you thought you would do. It kind of gives you a realistic view of whether you're working at a decent pace. Don't pause at any questions for too long. Like I said, for me personally, 2 minutes has been a guideline for myself. If I'm stuck on something for 2 minutes and I haven't written anything down, I'm still trying to find out a way to figure this out, I move to the next question and I'll come back to it in the end. Right? So I'd rather focus the time on something I could do easier and get some marks, and then come back to the ones that I'm not certain about. All right, any questions? Floor is open to you. Marks for the exam, yeah. Daniel, I think it's 120. Yeah, I think so. Just give me a second. I'm not sure if I have one that's open. Okay, let me just try and find one. Yeah, it's about 120. And last time I think it was 2 hours. It's a 2-hour long paper. And yeah, you get 120 marks in total. Okay, no questions? Everyone all good? Everyone's ready for the exam? I hope so. Okay, but remember, thanks, Kelly. If you have any questions, just drop me an email. All right. Thanks for joining, everyone. I appreciate your time. And I wish you all the best. Take care.
Thank you. Good night.